Go ahead and close your Chromebook. You do not need them. Three, two, one. There's going to be a lot. Hey, there's got to be a better way today. Okay, and so we're going to muscle through these, and then we're going to actually learn much better ways. Okay, so this first one, how is this different than what we saw last chapter? They had equal signs.
There's only one x. There's only one variable.
One variable. Last chapter, everything was y equals and then something like this. This time, they want to know, when does it equal 0? This is a huge concept that we'll do a bunch of, when does it equal 0. I put down here, we're not going to do the best method. I want to do guess and check to start. Can anyone tell me what they think the answer is?
4.
4, okay. So 4 squared is?
16.
Minus 36.
It's
It's wrong.
6.
6. So on this one, I don't know that you have to guess. Maybe you can look at it and you can tell. Here's a trick, though. There's something weird about this one. There are 2 answers. Yeah.
-6.
-6 also would work. We're asking the question, what number could I plug in for x to get this to equal 0? Okay? Yeah.
Do you always have to do like the outcomes for it? Or
We want to find all of them every single time. Okay. So the next one, somebody want to guess? Yeah. -3. That doesn't sound like a guess to me.
Sounds like the correct answer.
How did you get that one?
He probably looked at it and saw 6, 9, so like, why would you put the 3?
Okay, so if that was truly your guess, you would be right. If that wasn't your guess, then what do? Keep guessing.
I like
Okay.
this method.
Now, the fundamental theorem of algebra says whatever degree the question is, what's the degree here? 2, is how many solutions it possibly has. The fundamental theorem of algebra says whatever the degree is,
So it's a degree of 2.
degree of 2, is how many possible
Answers.
there would be.
So there's
So there's another answer.
So there could be another answer.
3.
Okay.
positive.
3's wrong.
So positive 3, I like that.
Not 6. You have to raise your hand.
Thank you. 36.
Oh, I'm not.
0.
Try -6.
Try what?
-6.
-6? Ah.
It's not that.
Ooh, close, close, close.
I said
9,
6,
9,
not
-9.
Ooh, what does that tell us?
It keeps getting farther.
So it has to be.
We now know where what is.
2. 2.
We now know what is.
The second answer.
If I'm okay, let me back up. If we're graphing this thing, we now know where what is.
Wait, it's 2.
Where there's when it's at
Where the vertex is. Where is the vertex?
36, 9, 36.
It's right in between what and what?
36.
No,
-3 and
-6, -9.
no,
-3,
no.
3 negative. 3
-9.
negative 9.
Why 3 -9? Why do I know it's right in between 3 and -9? Because that's where they're mirroring each other. What is the middle of 3 and -9?
It's
5.
4.
6.
-4.
What's the average of 3 and -9?
Oh, I thought it was
What's that?
-3.
How do you find average?
Add them and divide them.
Yeah, 3 plus -9
-6.
Wow.
divided by 2.
6.
It's
-2.
4.5.
Hold on a second. Wait.
What?
Is it 6
Why do you have a
Oh, I'm all
carpet?
better now.
Why do you have a carpet?
It's 4.5.
Isn't that what it is? Or like a flat with paint?
The answer is -6.
I told you guys to believe me.
What? It's
What is the average of -6 and 3?
0.
Adam. Wait, no, that wasn't the numbers. It was -9 and 3.
It's 6. -6.
How do you find the average? You add them and divide by 2, right?
It's 3. -3.
Sorry, I didn't hear
I
you.
said.
So -3.
That's the right answer.
That's what I said.
So if that's the vertex, and that's one of the times it hits 0, when is the other time it hits 0?
-3.
3.
I'm 3.
-6.
Ooh. I'm so
Negative six.
confused.
Hold on, I'll be right back.
Refresh the question.
I'm so confused.
0.
Resay the question.
I'm better, thank you.
What was the question?
Say the question again.
All right, let's write down some notes here, some concept that we need to know. Okay, we said there should be, we're coming back. We said there should be how many answers?
2.
2. If I were to graph these things and I want to know when they equal 0, I'm basically asking for these points. That's why we have 2 answers. Now you may say, but wait, Mr. McConnell, what if our graph is above or below? How many answers do we have then?
0.
We could have 0 answers. There's one more other option.
So there's no power, it would be 0 because
If our vertex is on that line, then how many answers will we have? 1 answers. 1 answers, 1 answer. So when I was up here and we decided that the vertex was at -3, and that was our solution, and it's the only solution. People were going, what's the other solution? Why are we going on, right?
2.
You said whatever the degree is.
Fundamental theorem of algebra says that the degree determines up to how many.
Oh, so it doesn't have.
You didn't say the up to part.
I don't. I don't.
Okay, I am recording this. When we're done, we will check at the end. Okay.
It was tapping.
Go on the red flag.
We'll review.
Go on the replay. It's in replay.
Mr. McConnell, I said it's good.
Do you guys know that expression, and then you'll eat crow?
What?
I am.
There's a red flag.
Yeah, you heard this? All right, some of you will be eating crow. Okay, Mr. McConnell, it's got to be a better way than just guessing blindly. What if we guess using a table? So in other words, let's be kind of more careful with our guesses. So I'm going to go ahead, and because there isn't a second variable, I'm just going to sneak in this y right here and just consider that side y. Because then our table is x, y. I don't know, that just makes me feel good. And we're trying to figure out, when does this y equal 0? Okay. So somebody give me a guess. Yeah. 1. So 1 squared minus 7 plus 6, 1, is that 0?
There's 0.
Wait.
Now he's getting it.
This is a really important question. Why do I not care about putting this one in parentheses, though I put this one up above it in parentheses? Because it's negative. If it's a negative, you want to put it in parentheses. So we got one solution.
I have a question.
Yeah.
If it's no power, would it be 0 answers?
No power, yes, because no power would be x to the 0 plus 5 equals 7. X to the 0 really means what? 1. 1 plus 5 equals 7. How do I solve it? When 6 equals 7, there are no solutions. I like that question. Yeah. -1. I think we want to go close here. If we can find the vertex, then we know we're in good shape. -1. So then I have to put in parentheses, -1 squared minus 7, parentheses, -1 plus 6. I get 14. Should we jump on the other side of 1 to see what's going on there? 4, all the way down to 4. I'm going to skip some steps here. I don't know what 4 is going to do. Go up here and I put in 4. It's going to be weird. I'm going to type in 0, 4. Hopefully that doesn't bug you. That gives me -6. I like this answer, I think. Okay. What next do you want to try? 2. We get -4. Let me ask you this. In terms of the graph, what is the graph? If we want to kind of think about this over here, which way is this graph going?
Down.
The U is up, right? So if our U on this one is up, okay, and we found out that one of the zeros is at -1, or is at +1, and then we got it for -1. I think I drew it wrong. Let me just draw these points here. 1, 2, 4, 0, negative. -1 was 14. What do we expect the 0 to be? Something like 6? Or is it going to be something like -6? If I look at this and I know it's got to be curved this way, then I think my answer is going to be somewhere over here. Helps us guess. How about 6? Go to our calculator. Type in 6.
Why'd you put zeros?
Because I had a negative in there, and this calculator is weird with deleting. We get 0. So our solutions are 1. Good. You can put it as x equals 1 comma 6, but that often looks like what to people? An ordered pair. So I kind of try not to do that.
Like, is there no like better way to do it?
There's got to be a better way.
Oh, I like the guess.
Got to be a better way. So let's go to Desmos. And I said, let's use Desmos and create a table. So if I go up here, and I don't think we've used this much, I go to, if I go up there and hit table, notice how it says X1. So if I go over here, all I did is I went up here and went table. 3, 2, 1. Okay, so then over here, I'm not allowed to type in y equals. I just say what y would equal. So in other words, on this side, I'm just going to type in that right there. Now the catch is I have to reference what this x is. What is this x called?
X1.
X sub 1. So over here, when I do x, I have to do x sub 1. How do I do that? If I type in x, and the next thing I type in is just the number 1, it automatically puts it as a subscript. And then I'm going to say I want to square that number, minus 5x1 plus 2. And once I do that, it's unhappy until I say what I want x1 to be. Someone give me a guess. 7. Says it's 16. Give me another guess. 0. And it's kind of cool because it even plots the points. 4. It's still definitely guess and check. 3. So here's something I want to point out. I like that someone said 3 because doesn't it look like something we got to get a 0 somewhere here? Okay. So I like that someone said 3. I go over here, type in 3.
2, 1.
1.
1.
Oh, wait,
Whoa. It's 0.
We already did
Oh.
0.
Oh.
2,
It's a negative.
What?
Negative
I
1.
It was
already
5, 5,
said
5,
negative
5.
3.
5,
Yes.
What? 3.
negative 3, negative 3.
4.5. 4.5.
I'm feeling
Oh, shoot.
Ran out of table spots.
4.5.
Hey, I'm feeling 6.
I'm feeling 4.5.
6.
Oh, 4.5.
Okay, finally someone said a decimal.
No, I was close. I was
Super
very
close.
4.2.
4.7. 4.7.
4.25. Now, let me ask this. Do I need to go further on the x or less on the x?
Further.
Further. The answer is like right here. So
4.8.
4.7. Too far.
4.6.
It's 6.
Too far.
4.55. 4.54.
5.3.
5.2.
You're going the wrong way.
5.1.
5.
Going the wrong way.
5.3. 5.6. 5.10.
5.6. 0.6.
5.9.
We're going to call that close enough.
Okay.
How do I say close enough?
It's
About the
Yeah.
The equals. Okay, that's an approximation symbol. We're going to say that it's about 4.56. Do we believe that there's another one on this?
Yes.
Absolutely. Where do you think it is?
I think it's
The other
below
side, the other
1.
side. 1.
Okay, below 1? Okay, I'm
But I don't think it's
1.56. I love that guess. Okay, not quite, because 1 is right here. 0.56.
We're getting farther away.
0.4.
0.35. 0.36.
0.5.
0.25. 0.36.
2.5.
So pause. I just did 0.45 and 0.5. One is below and one is above. So what is that number in between?
0.45. 0.46.
We'll call that close enough. Okay.
I'm good against it.
We want it to be 0. Okay. Okay. Now, Miss McConnell's got to be a better way. So I showed you all that. You'll probably never use that because why don't I just type in y equals x squared minus 5x plus 2.
Oh.
I knew you had to put something extra.
Oh.
Is that easier?
But how come that one's 0.4?
That one's like on.
Yeah, they're much. We were like, close enough, right? This is up to 3 decimal places accurate, right? Remember, Desmos rounds at the 3rd decimal place regardless, but they're much closer than we are. Answers I wouldn't have accepted over here would be like 5 or like 4, right? I want you to be kind of close.
The rounding kept getting questions wrong for me on.
Yeah, a lot of people.
On decimal.
Yeah, so you had to find the
It
vertex.
was 6.625.
Mm-hmm.
Yeah, I kept them with 0.3 or something.
Here's something I want to take a second and talk about. I kind of took my space up here, but I have this concept over here. I want to talk about zeros and x-intercept. So x-intercept means what? Where does it hit the x-axis? To find it, we always do what? We up to this point we just guess, but I said before we really want to be able to do what? Okay, so and maybe you would answer if I said how do you find the y-intercept?
Y equals 0.
Close. You're answering this question.
You're answering.
So really x-intercept means y equals 0. I want to know when does that equal 0. Okay. So, and the answer is always going to be x is something. Okay. So there's another term called the zeros. So you don't think it's a 2? So zeros are when means outcome is 0. Essentially, it's the exact same thing. They're all, in my mind, if you said x-intercept or 0, if you went to a math teacher or a college student who studies this and you said, oh, find the x-intercepts, and they found them, and you said, now find the zeros, they're going to say the same answer. Okay? So this, we want to know x equals what, or our answer is x equals, we want it to be 0. Okay? So the question is, what is our x for the outcome that equals 0? So why did I go through all that? Because there's an answer on here that a lot of students like to give me that's absolutely wrong. What do you think they think the 0 is, just looking at this first table? 2. 2 is not an answer. Why?
Because it's on the y side.
It's on the wrong side. I want to know, when does this side equal 0? That's the question. Not the left side, the right side.
He threw a cheese stick. He threw a cheese stick. Right?
Who did?
He threw a cheese stick.
Who did?
Why are you snitching? How do you have evidence?
Who threw?
He threw a cheese stick.
Who?
He said that's
Who
not
is
right.
he?
Carter, he threw a cheese
Are
stick.
you?
That's
Wait.
I need a paper towel. I think he's blaming right now.
Okay.
I'm not joking.
Carter, you look super guilty.
He was literally sitting and watching.
Where's the cheese stick?
Okay, where's the cheese?
Where's the cheese? Right there. He threw out my desk.
Where's
How are
there?
you gonna use it to pick up off the floor and put it in yourself?
AJ, you're my witness.
Is that 3 points?
Unfortunately, so we're not allowed to call out other people's points.
And why?
That's one thing. Second, I have to witness the throwing of the cheese stick, unfortunately. Now, let me clarify, witness. If I believe I know who threw the cheese stick, then they can win the prize. Witness doesn't necessarily mean I see it, but I see, like, if I see someone's hand go like this, and then next thing I see over there is a cheese stick going that direction, I can put things together. Now, in this situation, I saw nothing.
I'm watching them.
And
Now-
he was yelling.
I think
William's guilty.
someone in that row probably threw a cheese stick. I think that someone in that row, and not Luke because he'll take forever, should pick up the cheese stick and put it in the trash. And then we just move on.
Someone in this
Someone
room.
from that row.
You should shoot it.
Oh, Logan, that's a good special.
Wait, yeah,
He just
Logan
confessed.
Logan, why get the cheese stick?
New rule. You cannot have cell phones in this class. Cannot have cheese sticks in this class. Automatic violation.
Cheese sticks from? I don't
Automatic
this
violation.
class. I'm
At this point, I'm more worried about cheese sticks than phones. Okay. So we do not want this side, or we don't want this side to equal 0. We want this side to equal 0. Do you see where it equals 0? No. It says we're going to approximate. Something equals 0 when it goes from positive to negative or vice versa. Where does this go from positive to negative?
0.5 and 0.5.
0.5.
No, not that one.
0.5.
On the X side.
Oh,
The negative 0.5.
I'm asking on this side, when do we believe we go to 0?
Um,
I believe we're going through 0 somewhere in here,
and at the end.
and we expect a second answer or up to a second answer. So the question is it closer to the top number or the bottom number or right in the middle? Where do we think that is? We think it's closer to this bottom number. The answer is not 0. I want to know what is the x when we think this is going to be 0. So what x, we said it's closer to here. meaning it's closer to here, give me the number that you think that might be. I would accept a lot of answers. 0.1 I would not accept.
0.2.
I would not accept that. I would not accept that.
Negative 0.2.
No.
Negative 0.7. 1.
Let's have a girl give us an answer. Because
We're all just guessing.
Negative 0.7.
Instead of
Ask a smart. I mean,
negative 0.7 I would accept.
oh, come on.
So here's the deal.
Wait, did I say
We know it's between these two numbers, but it's closer to this one. You were giving me numbers that were not between those two numbers.
Wait, negative 0.6.
Boys.
Negative 0.6.
pass the time?
I would accept negative 0.6.
Negative 0.75.
I would accept that.
Negative 0.75 said that.
Okay, so I would really accept anything in between there as an approximation. We said the other one is here. Is it closer to 0.5 or to negative 2? We know it's closer to this one. So it's between these numbers, but it's closer to that one.
I'm gonna have to say
1.6, love it. 1.7, I love it.
1.7.
And I should actually be using my squiggles here.
0.7.
Okay, so given the table, that's why we went through the pain of looking at a table and finding it. Because I might give you a table and you can't go throw this into Desmos. Now, if it gave you the equation, but it didn't even give you the whole equation. So we have to, from the table, be able to tell. Also, this graph, right? If this was Desmos, we would just push here and we'd be done with it. Okay? But we can't because it's not on Desmos, it's on paper. Somebody give me an approximation of one of those zeros. 0.5. Now, I don't like 0.5 for two reasons. One, 0.5 would be over here.
Negative 0.2.
Negative 0.5, I think negative 0.5 is right in the middle. I like negative 0.4. I also like negative,
1.6.
love it, negative 1.6. If you were like negative 1, I would definitely mark it wrong, right? But you got to be kind of in that ballpark. This equation is talking about hitting a volleyball over a net. What's really weird about this equation to us? Yeah. It's just like we would think it's like the gravity one. How do I know it's not like the gravity one?
Negative 0.03.
No, negative 16, right? So it's doing something else. Let's talk about, I'm going to graph it real quick and then talk about what it's doing. Most of these, all we have to do is graph it and answer the question. Hitting a volleyball, here's the path, blah, blah. How far above, or about how far does the ball travel horizontally before it hits the ground? Where does hit the ground usually mean? 0. Now, what I want to point out here is that, and this is kind of probably the hardest thing with these, is knowing what our ordered pair means. This is my x. It tells me x is my horizontal distance. Okay? So this is my horizontal distance. And then y, or my output, is my altitude. What's altitude mean? Height. So my y is I'm going to use the word height just because I feel more comfortable with it. So when I'm looking at this graph, and I say right here, I click this button, 0, 12. That means it's not traveled from the person who's hitting it. It hasn't started traveling yet. And 12 means what? It's our y, which is our height. Okay? Do you think this person threw the ball up before they hit it? Why?
How are you supposed to 12 feet here?
12 feet. If you don't jump, can you hit a ball 12 feet?
No.
No, I don't think so,
How are you
right?
gonna hit it?
How high do you think you can stand? how high is your hand without jumping?
Like 8 foot.
Probably about 8 foot, right? So if you're hitting a ball, you're throwing it up and you're jumping and then you're hitting it. You're hitting it, this point right here. What's the 5 mean?
Seconds.
No, careful. Horizontal distance. It's traveled 5 feet and it is 12.75 feet in the air. Okay? This would be actually a really good model if you were a volleyball player, because what you really want from sports is to be consistent.
Excuse me, interruption. Would you please send Luke Massa to the office for dismissal? Thank you.
His life is hurting.
You okay?
Yes, physical therapy.
Oh, okay. So you want to be consistent. So if I modeled all 50 hits, we would want to kind of see what's happening and see if we can get consistent, and then we get a little stronger or whatever. Now, someone first period told me that a volleyball court is 30 feet long. Okay? From one line, what is it?
So would that mean the net is like 15 feet?
15 feet in the middle. So that means if I looked at this, I could go, okay, at 15 feet, did it hit the net? Does anyone know how high a net is? Okay.
10 feet.
7 foot.
No, it's not.
7 foot 2 inches.
It's taller than me.
It's like 10 feet.
But I can like I can see it.
Okay. So the ball's at 9.75 feet. So we could figure out, did it go over the net? I don't know how high it is.
I think so.
Did it stay in bounds?
Yes.
Yes.
How do we know that?
It's about 4:30.
Didn't it hit before 30. So we can do these hits, model them, and we can say, wow, okay, these look good. Okay. Now, with all that being said, what does the question ask? About how far does the ball travel before it hits the ground? It's this point right here. It traveled 25, and then it says round to the nearest whole number by Luke. 26 feet. Okay, is how far it traveled. This time 0 is what?
Height.
A height, right? And the other one is how far did it travel? Okay. All right. I think we're doing pretty good. Solve by inspection. Now I'm going to give you bad news and good news. I want you to notice that this note says 9.1
That's 9.4.
and this is 9.4.
Are we just skipping to it?
No, we're coming back to it. I don't think it makes sense to do it in a different order. So that means that our homework, our online work, is both
9.4 and 9.
9.1 and 9.4. But I cut like 9.1's like 10 problems.
Isn't it
Okay.
also
How many is 9.4?
Do Sunday, but some people said, can you have more time already? And I'm like, sure. It says do Sunday, but if you don't have it done, you can have the following Sunday. So solve by inspection. X squared equals 169.
Well, you just do the
Square root.
Square root. I love it. So we're going to square root both sides. Anytime I square root both sides, I am supposed to put a symbol here like that. I'm going to draw a little bit bigger.
Plus over minus.
Plus over minus. What that means is whatever I'm going to put here, like say I say answer is 5, that means I'm saying positive 5 and negative 5. Okay? Square root of 169 is,
plus minus
Plus 5 and
where's the square root? So on our calculator,
18.
we got this right here. Square root of 169.
13. 13 positive.
Positive or negative 13.
Is it always positive?
Anytime you square root, we're going to get a positive or negative. This is how we get our two answers. Now, we're in the simple. When we get over here, we might not get the same number. This one. What do I do first?
4.
Okay, so,
Wait. Does it have to be a negative 4 and a positive 4?
okay,
No, that's not possible.
not possible.
Undetermined.
No solution.
Because what is the square root of what number times itself equals negative 16? What number
4, negative 4.
equals negative 16? Negative 4 and negative 4.
So if it's ever negative, it's
No, that doesn't work, does it?
It's no
Okay, so it's no solution. Algebra 2, you're going to learn how we deal with that in mathematics. We call it imaginary numbers.
I am imagining.
Here's a big star I want to put on this. How many variables are in this first question? How about the second one? How about the third one? 1x. We just solve it. And you're going to forget this, and this is the easiest part, and you're going to try to make all of these much harder than they are. But if there's
only one x, we solve it.
just 1x, we're going to solve it.
Like,
So,
just like a normal-
just like normal, we're going to subtract 25 from both sides. 2x squared equals 50. What do I do next?
Are these not, is this also part of 9-4?
Yeah.
X equals 5 plus.
X equals 5 or negative 5. So you could write plus or minus 5. I'm giving you the 3 solution types. What are the 3 solution types? Fundamental theorem of algebra says there are up to 2 solutions. This is a 2 solution. I don't want us to be confused. Sometimes people think that means 1 solution. What are the solutions based on this first one? Positive 5 and negative 5. So only 1x, solve it. Subtract 15 from both sides. 2x squared equals negative 22. No. Negative 9? No. 8. Thank you. Divide by 2. X squared equals negative 4.
Unsolvable.
No solution. If I were to graph this, would it go through the x-intercept? No. This last one, people want to FOIL this out. They're like, wow, I got to multiply that. But don't. We're going to subtract 2 from both sides. 3x plus 5 squared equals 0. How do I get rid of a squared? Square root. Square root both sides. I should write plus or minus over here. What is square root of 0?
0.
What's the difference between adding a 0 and subtracting a 0? Nothing. So that plus or minus means nothing in this problem. So it goes away. Subtract 5. Divide by 3. X equals negative 5/3. So we have the 2 solution, the no solution, and the 1 solution. That's how they look when we do these.
Why can't you just distribute it?
You could, but you're making more work for yourself. Their fundamental theorem of algebra says there are up to 2 solutions if it's a degree 2.
So it's a positive.
Okay. Next one. So I want you to solve this, but if it's not a perfect number, I want you to tell me what 2 numbers it's between. So let's just solve it and then go from there. Divide by 5. X squared equals 25. Yep. Is that a hand? Oh. X equals
5.
plus or minus 5. Easy peasy. So just solve it. This next one, what's our first step? Okay, what's the other thing you could do other than dividing by 1? You can multiply by, no, by 2, by negative 2, really. Either way, you'd get the same thing. This just becomes x squared. Negative 36 times negative 2. Is that 72? I want to know what 2 integers this is between, because square root of 72 is not a nice number. What's the next perfect square going up?
9.
Okay, 9. 9 squared is what? 81. And then what's the next one below it?
64.
64. So this 72 is between those 2, right? So state what it is possible. It's going to give us a decimal. I could throw it in the calculator, but it doesn't say that. It says state which 2 integers it's between. What is it between? 8 and 9. So just kind of a weird question. We have the power just to throw it in the calculator, but it doesn't want that. It wants to know what two numbers it's between. Pythagorean. What's his most famous formula? A squared plus B squared equals C squared. These are the sides of a triangle, of a right triangle. Okay? This side here is called the hypotenuse. Hypotenuse. These are what's called legs. Okay? The legs are by the right angle. Okay? So these are the right angle.
Is the hypotenuse like the weird line? Like the long one?
The hypotenuse is always the longest. Now, sometimes in the more advanced math we get, they're not going to draw it like this. They might draw the graph like this, and you just got to know it's the longest one. But they're being nice to us. This has to be C. Doesn't matter which one we call A. A, B. Formula says that it's 4x squared plus 500 squared, the way you said that, equals 6x squared. 4x squared is 16x squared. 500 squared. 25 with how many zeros?
4.
4 equals 36x squared. We only have one type of x, which is an x squared. So what do? We can solve this.
You can, that's 2x.
Let's subtract 6x squared from both sides. Ran out of room. I get 25 with 4 zeros equals 20x squared. Oh. Divided by 20.
No. You don't have to do anything to subtraction.
250,000 divided by 20. And then I'm going to square root it. It gives me that x equals 111.8. It's really plus or minus. Why do I throw out the minus in this answer?
I don't know.
Because you can't have a negative length or negative sides. We drew a triangle. So really all I think is it's 111.8. We do not have it as a standard to learn about what nonsense they did over here. So how can I figure out which is the correct answer if I think the correct answer is 111.8?
Put it in Desmos.
Put what in Desmos?
1.8.
No.
All of the options.
All the options. Now, let me ask you this. That seems really... Oh, I did the wrong thing. Okay, I'm sorry. This is a different problem. My bad. That's the answer to that problem. My bad. Sorry. So we know that x equals 111.8. It says find x and the unknown side length, so I could plug that back in. I'm going to skip that to come to this next problem. 4x squared. I'm going to subtract 7 from both sides and get 18. Divide by 4. X squared equals, is that 4.5? Ah, man. I'll finish that one tomorrow.
Wait, did we stop So finish this.
You know everything you need to know to do the group quiz.
Showing work, can you just guess? Is that showing work?
Must show work on the solving ones.
Oh, those are the solvers.
So add 7, divide by 5. Solve using a graph or a table. Just draw the graph and tell me the answers.
So like the graph on this guessing.
I mean,